Our questions about the world begin almost as soon as we're aware of it. This natural inquisitiveness helps shape the development of the human species.
What science and engineering has brought us over decades and centuries and millennia has been absolutely astounding. There's no real reason to think that will stop. Our lives will continue to change as a result of science and engineering. It only makes sense that everyone should learn science.
As we encounter natural phenomena, we seek to understand what is happening around us. Not only does science help us answer these questions, it is at the root of how and why we ask them.
As we enter well along into this new century, this is really going to be, and it's well understood that this is going to be a century of science, of informing people about what science is finding out about the natural world.
Inquiry is an important part of science because it really is science. It's easy to get the impression that science is a list of terms or a list of concepts or topics, but really what it is at the heart is the process of conducting inquiry.
Science education is a journey that takes us from wonder to inquiry, curiosity, investigation, and finally, to understanding.
To get a true understanding of the processes of nature, there's really a rather small number of fundamental laws and concepts that govern the behavior of pretty much everything.
What we have done in developing the 8+1 is to try to capture those laws and those basic concepts which help us to understand that natural world. Those 8 concepts, and hence what the 8 is in the 8+1, derive from 2 basic questions of what are things made and how do systems interact and change. The +1 has to do with the question of how in science do we know what we know, which comes down to data collection, inquiry, things that pertain to actually trying to study the natural world.
Scientists agree that pretty much everything can be attributed to these 8 fundamental principles, which begs the question, why isn't science taught this way in our schools?
When we look at science instruction in the schools, it seems to be antithetical to the way science operates in the world. That is, the natural world seems to operate on this basis of these very simple laws. Yet when we get to schooling, we simply try to teach children not those laws, but we give them lots of facts, lots of definitions, lots of vocabulary, and we think that's science. And what it is so overloaded that it just becomes almost an impossible task for children to learn that. And so they get turned off by science and they soon lose interest in it.
What the 8 fundamental principles do is they give you the tools that connect all the principles between these different courses. So the content knowledge will still be split into these different areas, but the understanding, as opposed to the knowledge, is coming by the principles that tie them together.
Many people ask, how are our students doing in science? Are they doing well? Well, there's 2 pieces of evidence that suggest that they're not doing well at all. The percentage of U.S. children in 4th grade and in 8th grade is only about 1/3 of our children test at being proficient. And by 12th grade, only about 20%. That implies 80% of our kids are leaving that world of high school without being proficient in science. Secondly, if you look at international studies, we were about 23rd out of the countries that were studied. For a country that thinks of itself as being a technological leader and a leader in the scientific world, being 23rd out of the nations is not particularly encouraging.
The way science is frequently taught really does not promote that view of science being a process by which people, using their creativity and their imaginations and their ingenuity, go about trying to understand and explain the world around us. Instead, it tends to promote the view that science is something to be memorized and it really has nothing to do with our lives. It doesn't have to do with human process of discovery.
Scientific discovery is moving at such a pace now. 5 years from now, even 2 years from now, there's going to be really important discoveries that have a huge impact on our lives, and they weren't in our middle school or high school curriculum.
What if science could be taught in a new way, that helps students to question their observations, make connections, then see the relationship between natural phenomena. Since 2006, a group of prominent scientists and educators have been meeting at Michigan State University to accomplish just that. With the support of the National Science Foundation, these experts aim to identify these fundamental science principles and form a new basis for how to teach science.
These concepts are ones that are agreed upon by biologists, chemists, physicists, geoscientists, astronomers. We all agree that these are the basic ideas that allow us to explain almost everything we see in nature. The 8+1 concepts can help students, children of all ages, learn about systems. The concept of the system really permeates most of the 8+1 concepts.
The essential component of life is the cell. The cell is part of a system of tissues, of organs, of organism. Each of those is part of a system.
Inquiry is both the curiosity, it's the thing that's driving you to understand, but it's also the tools you need to go from the curiosity to the understanding.
They allow teachers, curriculum developers, students, everyone to be able to see the connections between the sciences.
What should science, based on the 8+1, look like in the classroom?
The traditional science disciplines are intimidating. They are difficult. We have a large set of students that shy away from the traditional science disciplines.
As they sit as an articulation, if you like, of the distillation of how the natural world works, they're very abstract. It's hard to get a handle on, especially for teachers, to be able to teach it to kids.
It provides a way of thinking that makes it coherent. There isn't an endless list of concepts to know, facts to learn. Any conversation I have with elementary teachers can be turned back and related to the 8+1 concepts.
When I talk to teachers about thinking of new ways to teach science and the 8+1, I talk about the 8 as pillars that provide a basic structure for helping students build their knowledge.
Teaching skills about inquiry, about asking what are things made of. Those are skill sets that can begin early. And as a student matures through the system, the student can better understand these changing conditions that they will be living in.
What the 8+1 does is it enables them to restructure their thinking so that instead of going down the discipline path, they can look at what they're teaching, reflect on the bigger picture of what science is about.
Implementing the 8+1 philosophy gives teachers a new way to bridge concepts in the classroom and develop their students' thinking about how to solve science problems. Without the confines of thinking within a traditional discipline, students are free to solve problems, including those encountered in everyday life, drawing from their knowledge of biology, chemistry, physics, mathematics, and other subjects, and apply this knowledge in new ways.
It's important because it helps you take control of your life.
New areas are emerging in science all the time. The nice thing about the 8+1 is that it allows you to get into some of this complex new fields even through simple lessons, even at the 5th grade level, where you can open the door and say, all of this complexity can be understood by 8 fundamental science concepts, and how we know and develop this new knowledge can be learned by learning how to do inquiry.
The 8+1 is not a new set of science standards. It supports basic concepts included in many state standards for science and capitalizes on resources already available in the classroom.
The 8+1 can be easily adapted to them because they are the fundamental ideas of science.
It better enables our staff to work together as one on behalf of our students, which I think is a good theme, a very significant theme in all good school districts.
The 8+1 provides a way for teachers to structure their thinking about the most important ideas in science and make the ideas coherent.
There is a growing realization that the solution to big problems, global warming, environmental degradation, disease and pandemics, water and food security, will require an aware, informed, and science-literate citizenry.
This is a crisis that we are in this increasingly technological world where that kind of knowledge is ever more important. We're just not giving our kids the kind of background that enables them.
It's absolutely crucial to have a science-literate public. In today's world, our lives are so complicated. We make so many decisions every day that affect our personal lives. We make decisions about whether to buy organic milk for our children. We make decisions about whether or not to use paper or plastic at the checkout line. All of these decisions have implications for our own lives, but they have implications for society, and they have implications for the planet as a whole.
What we have is a real chance here to really engage children in an understanding of science that isn't based on a lot of isolated facts, but really gives them a chance to understand the world, to think about the world. This is one of the greatest chances I think we have for our kids in science, and I think we owe it to our children.
Throughout history, the people who have changed the world did so by thinking outside of the box. They sought out new ways to understand our world, to open our eyes to new solutions, and to change how we interact. As scientists, educators, and parents alike, we must ask, what challenges lie ahead for our children? Are we preparing the next generation of great science thinkers? Will they have the knowledge and skills to solve problems we can't even imagine today? Through efforts like 8+1 Science, we believe this answer will be a resounding yes.